Hello, let me talk about the problem 2. It is about the signal we transfer between some nodes and through the channels, and we are given that the probability of zero signal from the start node is 0.2, and the signal from start node is 1, which probability is 0.8. So we can have the start distribution written like this, and we know that there is a state transformation matrix which can be represented by 0.6, 0.4, 0.3, 0.7, and multiply by the vector of probability. Then we can have the distribution of signal of the next node, which means px2 is equal like this, and we will get the number is 0.63 and 0.64. So which means let me explain why it is 0.63, which is get by 0.6 multiplied by 0.2 and add 0.3 multiplied by 0.8, and then we will get 0.36. So it means we will have the probability of x2 equals to 0 is 0.63, and probability of x2 equals 1 will be 0.64. So this is the first question. The next is about find the probability of px3 equals to 1. We can easily get the distribution of px3 by multiplying the distribution of px2 by the transformation matrix. And then we will have the distribution of x3. Then we have px3 equals to 1 equals to 0.592. Okay, the third question is, given x3 equals to 1, and what's the probability of x1 equals to 0? First, we will use the conditional probability function, and it will becomes px1 equals to 0 and x3 equals to 1 divided by x3 equals to 1, and the upper will be x can transfer to x3 equals to 1 given x1 equals to 0 multiplied by px1 equals to 0, and we will remain the lower. So our problem becomes to solve what's this probability? Okay. So the probability given x1 equals to 0, what's the probability of x3 equals to 1? Which means we can multiply the transformation matrix by to the power of 2, and we can know given x1 equals to 0, what's the probability of x3 equals to 1. So we can just calculate the transformation matrix to the power of 2, and we will get the answer is like this. So these 4 sections means, like, the first section means the probability of x3 equals to 0 given x1 equals to 0, and this probability means just what we want to know, that given x1 equals to 0, the probability of x3 equals to 0. So it is clearly that these 2 probabilities can be added to the sum of these 2 probabilities is 1, and the sum of these 2 is 1. So we will know the answer is 0.52 multiplied by x1 equals to 0 is 0.2, and x3 equals 1, we calculated it in the former problem. So it will be approximately 176. The fourth question. Find the limit when n goes to infinite that pxn equals to 0. So we know that we can determine the probability of each state by multiplying the transformation matrix to the power of n times on the probability vector of the beginning state. So the limit problem becomes to know what's the limit of the matrix to the power of n, and we can solve it by calculating the limit of the matrix, or in the other way, we will know that if the state probability will have a limit, we will know that if we assume that it is p and y minus p, so when we multiply it by the transformation matrix, it will remain the same, which means this is its limit, and it will still become p and y minus p, so that we can solve it like 0.6 p plus 0.3 y minus p equals to p, and we will have p equals to 3/7. So therefore pxn equals to 0, its limit is 3/7.